And now we're going to be talking with Roger Gentry, who is going to be talking to us about domains DNS, the map that makes the internet. And Roger's managed the security and compliance for clients across the United States, providing CTO, CSO level consulting to a variety of industries. He's worked with customers to achieve successful compliance certifications from PCI, ISO, SOC, and more. And we are incredibly happy to have him here today to teach us a little bit more about what all of that means.
Awesome. I've got a slideshow that I just need to get up here somewhere. So we're just go ahead and do that. So today we're talking about domains, DNS, and the map. But first I want to tell you about maps a little bit, specifically latitude and longitude, which are the horizontal and vertical points that give us these magical numbers that we use to find things on a map. For example, this airplane boneyard in Tucson, Arizona. It can be accessed sometimes by searching for this on Google, but more directly by using the latitude and longitude. And the reasons why this is important is those are very similar to IP addresses, which are the numerical designation for every device, both on the internet and on your local network, which is a block of numbers, which is 192.168.1.1, which is how we identify things that we're looking at for our networks. Each one of these things comes from either your network router or your ISP. There's some that are different. There are some that are public and some that are private. The ones that are private are the ones that are within your local network, and the public ones are really more what we're focusing on today. Those are assigned by the ISP, which is your internet service provider, which is bought or rented or leased or has been allocated from a central registry that says these are all the IP addresses that you can assign to your users. So let's talk about that for a little bit. So public IP addresses are kind of the backbone that makes the internet. They're like the phone numbers, and everything has one, from the ATM machine to the phone in your pocket and just about everything in between. And a lot of times they're not only accessible, but they're vulnerable to any sort of open port or any unnecessary thing that we have going on there. But memorizing IP addresses could be a little bit difficult, just like memorizing GPS coordinates are a little bit difficult. After all, it's just a numerical label that we're assigning to everything. And humans are not naturally very good at memorizing a ton of numbers. I mean, just imagine if you had to type in the IP address for Google every time you wanted to search for something. That would be a nightmare. So there are some similarities between both the IP address and the GPS coordinates. They're long numerical things that identify a unique location or device. We have GPS locations that will tell us any place in the world, and an IP address will vaguely get us there, but we have some things to consider. So as I mentioned before, we have a central registry of IP addresses that are then designated to these regional internet registries. So if you were really into kind of viewing the matrix or understanding every IP address, you could look at one and know just by the numbers inside which country that it's associated with. But that's kind of like an address book for every city, and it's just too much. And that's where domains come in handy. So domains are kind of the human readable way that we are getting this information, like going to google.com or Facebook. It's the branding, it's the memorable online identity, and it's kind of the thing that we all look at when we're accessing a website. If you know me, you know I love domains. I've got hundreds of them because, well, they're fun to get. Everything from my own name to, Big Rat Dot Pizza, which literally is just a quote about how it's meal prepping if you buy a whole pizza. But they're also significant for branding. Like a good domain is worth its weight in, well, gold in some cases. They've sold for tens and hundreds and sometimes millions of dollars just because some people want to have a short, memorable domain. Like look at Twitter. Like they imagine if their name was tweetthisnow.com. It's not as cool. So domains give us the ability to find things on the internet, but they require a few steps. One of them is using a domain register. So one of these guys, for example, named Silo, Two Cows, Hover, Gandhi, will allow you to go through and register a domain. But what actually happens when you register that domain is you're collecting something that's available, meaning nobody else on the internet is using that particular set of numbers combined together with a .com, .net, or whatever. And you go through and you provide the required information for registering that domain, your payment information, and how long you want to register that. Once you have filled out that form and submit it, you get the domain. But unlike buying a piece of property, you still have to pay kind of taxes on it every year. And if you forget and that domain expires, well, it's open up for someone else to buy. So it's kind of more like renting. You're renting the domain from the internet for your usage. And DNS kind of connects the two. So we've talked about the IP addresses, which allow us to find the resources on the internet, and the domains, which allow us to have a brandable way to do it. So the DNS servers are actually responsible for the whole bit of all of this and how it works. And if you've ever tried to learn any about this, the videos and the education kind of dives into this a lot. But for our purposes, we're just going to do a high overview about what all of this means. So DNS translates to domain name server, which is what happens when you type in google.com. It goes through a series of requests. The first one is to whatever's locally configured on your machine to say, is this a machine that's locally on this network with a private IP address? If not, it goes to the next step, which is your DNS resolver, which says, do I have this cached in memory to understand where to go? If not, go to the next step. This goes all the way up to the root directory, and each domain, like a .com, has their own sort of registry. So for each .com, going a little fast here, for each .com, .org, .edu, each has their own set of servers, and inside those servers is just a list of other servers to check. So when you register, RogerGentry.com, it's listed in the .com registry, but the only thing that's actually there are your name servers. Those name servers are what contain the records for everything that's on RogerGentry.com, for example. But that's not the only type of domain that we have. We have a lot of different types of top-level domains, as they're called. Everything from what we're used to as .com, .orgs to country code specifics. These ones are assigned for specific usages of the country, like .us, .uk, which .us doesn't get you use a whole lot. UK and .ca I see a lot more for identifying things like Amazon.com specific for the UK or specific for Canada. But we also have a lot of these newer domains like .app, .io, .shop, literally any extension you can think of can actually be a top-level domain in this case. Google actually has .google, and I think Apple owns .apple. But what happens when you access any of these domains is just the same. It goes up the ladder to check to see if you know it locally, your resolver knows it locally. If not, it reaches out to the Internet Address Book to find it. So when I say all of this is like a map, this is kind of the place name instead of saying, the GPS locations for the United States, we would just say the United States, and it's generally recognized what that means. If you don't know it, you'd go look it up and find out what that means and translate it backwards. So let's talk about some of these records here, because we talked about the domains, which translate from, say, example.com to an IP address. This one's a private IP address, so it actually wouldn't go anywhere. But then we also have some other things. So we have a CNAME, which is where you can take a subdomain like www. Which actually stands for the World Wide Web. Not commonly used as much anymore as we used to when we started doing all of the magic of the internet. And that translates it to a separate domain itself. So you can have multiple domains pointing to another server, and then this record would translate to the IP address. It's one to the other. Same way we'd look up the domain, it kind of creates the whole circle. But furthermore, we also have other types of domains like MX records, which is how you would configure an email across your own domain. So instead of using Gmail, you would have Roger Gentry as your mail server, for my instance, and then anybody that wants to email you just has your email address on your domain. But if you ever try to change mail providers, you no longer want to use Google, you want to switch to somebody else, you can just change the MX records on that domain, and the new emails that flow into that will then be routed to the correct destination. Same thing, that gives you kind of the power to self-host and control where your presence on the internet is going to be, and route that to somewhere else if you want. It gives you kind of control of your online presence, your own internet, if you would. But there are a lot of other records. The only other one that I want to really talk about is the text record, because these are the ones that are going to be used most commonly. Like if you've ever set up a website or doing anything to have a presence outside your local network and you have a domain, these are pretty commonly the 4 records that you're going to manage or do anything with. Text records can be used for all sorts of things, from validating your mail servers are correct, to securing your domain with your register, or to just having some silly information that happens when you look up the domain. So if you do a lookup for the text record who.rogergentry.com, it will give you an idea of who I am. And I mean, not this isn't something that everybody has, but it's certainly something that you can take advantage of, using the text records to store information that, well, whatever you want. I've tested some things, just kind of seeing like the limitations on that. And some providers have a cap on the number of characters, but if you can fit it into a tweet, you can pretty much fit it into a text record. So you can have some fun with other uses for DNS that are non-standard, that are not trying to route somebody to their destination. But at the same time, DNS has a lot of sort of security issues around it, such as DNS poisoning or spoofing and other attacks. And a lot of this comes down to kind of DNS reflection attacks. That's a common form of a dynamic denial of service, where you use the DNS server to request the records for basically your attack vector, and then it amplifies that. So a lot of providers have safeguards in place to prevent those types of attacks from happening. Same thing with DNS spoofing and cache poisoning. That's something where instead of attacking their authoritative root record on the correct server, they'll go into that resolver, which happens before it checks the larger internet registry to where it's supposed to go. So it could exist on your local network. Your router gets hacked and somebody's going through and says, anytime that you're trying to access your bank, instead we're going to send you to this fake bank. And it looks correct because the DNS is, apparently there, because we've poisoned, what your record, your computer thinks it has. So there are some things that have implemented, as when I say we, I mean the overarching internet beings that manage these things, such as the DNS security and DNS over HTTPS. So the first one works with your register and creates an encryption key that you then store in your DNS that says these are the things that are supposed to be correct between the two. If they are not correct, that means that something happened in between you getting the record and us posting it in the cache or something else that is not valid. And so your browser would know to say, hey, I'm going to check something else before I route you to that site. And DNS over HTTPS is interesting because DNS as it exists now is its own sort of protocols. Your computer knows how to do all of these things built into it on the operating system that the browser uses to get this information as to where to take you on the internet when you type in a domain. But DNS over HTTPS treats DNS as if it was a website, which bypasses a lot of censorship that can happen when they're blocking the protocol for DNS or redirecting that. And so this sends it instead over as if it was its own website, and then pulls the DNS over a secure connection. So layers upon layers of routing that can happen. At each step, there's a problem, there's vulnerability, and then there's ways that we can mitigate against that. So part of the registration process, when you're buying a domain or setting this up, you have to submit your own information in. And if you're just doing this for the first time, you may not understand that when you buy a domain and you have it registered to you, just by default, all the information that you submit for that registration process is public. And you can just look it up on some of these websites. gwhois.org is a good example. And you type in the domain name and it will oftentimes tell you what the owner is. Now, not everybody necessarily wants that. If you're a large corporation that has a mail department that can filter through the number of spam that you're going to get there, and oftentimes they want to have that to build a layer of trust to say we are the owner of this site. But for the most part, that system has become less and less useful as it's most commonly used for spammers. So you can actually set up your domain, and a lot of the providers will offer what's called private registration. So they have a proxy that they set up so that any contact that is sent to the contact that's listed for your domain register is then passed over to you. But your actual private information doesn't show up in these publicly available databases, which is a requirement for registering the domain and having it available, is being able to say we have a publicly available technical content. And that comes from when all of these standards were designed and built, we wanted to have an overarching address book as when there's a problem where we have questions, who to go to. And so that is the end of the slides that I have. And kind of just a summary there, if I was to give this in a few sentences, DNS and domains are basically the translation of country names to their locations as a GPS point on a map. So when you think about these things in the future, you say domain, think country, and then translate that to an IP address. So it's not that big of a mystery. It's not that big of a crazy black box as sometimes it is perceived, but it is inherently complicated. And I hope this kind of simplifies it a little bit.